All right, so this is the Unit 1 study guide. I already started filling it out without realizing that the screen was not recording. So anyway, let me go through this again. Variables, you've got two types. You've got categorical and quantitative. Remember, categorical is categories and quantitative is numbers. Another word you might see on the test is qualitative for categorical. So categorical and quantitative. Remember, if you have a quantitative variable, we can split that up into two more categories, discrete and continuous. So discrete would be like the number of siblings you have, like 1, 2, 3, or 4. You can't have between 1 and 2 siblings, right? So continuous is the opposite, right? Continuous means that there's no separate units that you have to worry about. All of the units are just continuous. It can be in between certain numbers. All right, so that's it for variables. Now let's talk about measures of center and measures of spread or variability that mean the same thing. So the measures of center that we talked about were mean, which is your average, median, which is your middle number. Remember, if you have an odd number in your sample, an odd n, you will have a true middle. It'll just be the middle number in the data set. If you have an even sample size, you're going to average the two middle numbers together. It's going to be in between two numbers in your data set. All right, and then we've talked about mode occasionally, but that's the most occurring number. The most occurring number in the data set. All right, measures of spread. We have your range, which is your max minus your min. Your IQR, which is your Q3 minus your Q1. Your standard deviation, which is how far from the mean the data is. And then we also briefly talked about variance. Remember, variance is your standard deviation squared. All right, so remember, measures of center measure the center of the data, and then your measures of spread measure how spread out the data is. So out of all these, which ones are affected by outliers? So I'm going to put a little asterisk right here and say affected by outliers. All right, between these, our mean is the measure of center affected by outliers, because you're adding up all the numbers together and dividing them by your sample size. So when you add up the numbers, your outliers including that sum, so it skews your mean, right? Median and mode are not affected by outliers. Over here, your range is affected by outliers, right? Because your outlier is going to be your min or your max, because your outlier is so far away from the data. So it's going to make your range huge, right? Your IQR is not affected because outliers are not included within the middle 50% of the data, or they wouldn't be outliers. So IQR is not affected. Standard deviation and variance are affected by outliers because standard deviation is how far spread out the data is from the mean, and if you have outliers, it's going to affect that standard deviation. And then variance is standard deviation squared, so if it affects the standard deviation, then it affects the variance. So keep in mind, these are the numbers that are affected by outliers: mean, range, standard deviation, and variance. Median and IQR are not. All right, we also talked about transforming data. So remember, transforming data is when we made a mistake collecting data and we need to add 4 to every number in the data set, or divide every number in the data set by 2, those types of problems. So remember, most of the time you change the mean and the standard deviation along with all of the different numbers in the data set. There's only one exception. So if you're adding or subtracting every number in the data set, it does not change your measure of spread, so it stays the same. So any measure of spread, your range, your IQR, or your standard deviation, stays the same if you add or subtract every single number in the data set by the same number. Everything else changes. So if you multiply every number, you're going to multiply the mean. You're going to multiply the standard deviation. You're going to multiply the range. If you add or subtract, that's going to change your measure of center. Remember, measures of center are what we talked about up here. Measures of spread are what we talked about right here. So just keep that in mind. It stays the same if you add or subtract, but everything else changes it. All right, displaying one variable data. So we talked about box plots, histograms, and stem and leaf plots. So remember, a box plot is made with a 5-number summary. So the 5 numbers that summarize box plots are your minimum, your Q1, your Q2, your Q3, and your max. So those are your 5 numbers. And remember, your Q2 is your median. This is what your box plot looks like. Your min, your max, your Q1, your Q2, and your Q3. Now remember, it's split up into 25% chunks. So 25% of the data is between the min and the Q1. 25% is between the Q1 and Q2. 25 is between Q2 and Q3. And 25% is between Q3 and the max. And remember that your IQR is your Q3 minus your Q1. So this number minus this number. So your IQR is this spread, this box spread right here. All right, with histograms, you've got 2 axes. You've got frequency on this side. And then you've got intervals over here. So let's say my first bars for these intervals. I'm just going to draw a little histogram. They should all be about the same width. I'm going to write intervals down here. So on the test you might be asked to figure out what interval the median's in. So you know that the median is the middle number, so the first thing you would do is figure out what the n is, or how many numbers are in the data set. And you do that by looking at the frequency. So there's 2 numbers in this interval, because it hits at 2. There's 3 numbers at this interval, 2 here, and 4 here, because I'm just looking to see how high the bars go. When I add them all up, that's going to give me an n of 11, so that I know my middle number is going to be the 6th number, right? Because 6 is the middle number in 11. There's 5 numbers below 6, and there's 5 numbers above 6. So the 6th number is the median. So my median would actually be in this interval right here. And I got that because the first 2 numbers are in the first bar. The first 5 numbers are in the first 2 bars, because 2 plus 3 is 5. And the first 7 numbers are in the first 3 bars, right? So 2, 5, 7. So I know the 6th number must be in this bar right here. So that's how I know what interval the median's in. So that's how you figure out your n, and then go from there. All right, remember stem and leaf plots. You have a stem in the middle, and then you've got different leaves out to the side. So on this side, my minimum would be 7, and my maximum would be 38. Over on the left side, my minimum would be 18. Remember, this is the stem and this is the leaf, so 18 would be my minimum, and my max would be 42. All right. All right, low outlier and high outlier test. So remember, if you're trying to find outliers in a data set, you need to do the low outlier and high outlier test. So the lot is going to be your Q1 minus 1.5 times IQR. And your hot is Q3 plus 1.5 times IQR. All right, let's do a quick example of finding different outliers. What if my data set had a Q1 of 10 and a Q3 of 21? So I'm just going to plug that into my hot and my lot. So my low outlier test would be 10 minus 1.5 times 11. Where did I get the 11 from? Remember, your IQR is your Q1, I'm sorry, Q3 minus Q1. So I just did 21 minus 10, and I got an IQR of 11. All right, so here's my low outlier threshold. (10 minus 1.5 times 11). So negative 6.5. And then my high outlier threshold is going to be 21 plus 1.5 times 11. 21 plus 1.5. All right, so that means any low outlier in the data set would have to be below the number negative 6.5. Any number that's outside of this high outlier test, meaning it's above 37.5, would be an outlier. So if I had a minimum of 8 and a maximum of 40, would I have any outliers in this data set? Yes, I would. I would have a high outlier because my max is 40, which is outside my high outlier range. All right, we also talked about shapes of distributions, so let's go ahead and label all these different shapes. So right here we have symmetric. It looks like a normal distribution. Here we have skewed right because my tail is to the right. Here I have skewed left because my tail is to the left. Down here I have a uniform distribution because it's all roughly the same size. And right here I have a bimodal distribution because I've got two peaks. All right, so remember when the data skews right, it's going to skew the mean with it. So my mean gets skewed toward the tail, right? So in this situation, my mean is going to be greater than my median because the mean is getting skewed. The opposite is true in a left skew, right? My mean is being pulled toward the skew, so my mean's actually going to be less than my median. So make sure you know that about skewed distributions. All right, we've also talked about describing distributions and comparing distributions. So describing distributions, there's only one distribution involved, and we describe them using these 4 letters. Remember, S stands for shape, O stands for outliers, C stands for center, and V stands for variability. So you're just going to have 4 sentences. One describes the shape. One tells you if there's any outliers. You perform your hot and your lot, and you say if the distribution has any outliers. C is your measure of center. So you're going to just note what the measure of center is, and you can use the mean or the median, whatever they give you. And then with variability, you're going to reference one statistic of variability, whether that's the range, the IQR, or the standard deviation. Just use what they give you and mention that's the distribution variability. When you're comparing distributions, you have 2 different distributions. So you have the same letters, but this time you're going to talk about both shapes. So each distribution has a shape. You're going to mention both shapes. The O's, you're going to mention outliers for both data sets, not just one. And then for center and variability, you need to compare mean or median. For variability, you need to compare range, IQR, or standard deviation. And when I say compare, you're going to say the mean of distribution 1 is larger than the mean of distribution 2. The range of distribution 1 is bigger than the range of distribution 2. So you're going to use comparing words like that. So these 2 are basically the same thing, just describing, you're just looking at one distribution. Comparing, you're looking at 2, and you need to make sure you're using comparing words. All right? Cumulative relative frequency. So to calculate what this is, you're going to take your cumulative total over your grand total. So here's a little cumulative frequency chart right here that we're going to use as an example. So here are my intervals, and this is the number of data that fall within each interval. So I have 6 pieces of data that fall between 0 and 10. I have 7 that fall between 11 and 20. I have 5 that fall between 21 and 30, and I have 2 that fall between 31 and 40. All right, so my example is going to be to find the cumulative relative frequency for the interval 11 to 20. So I'm looking at this interval right here. So all I need to do is add up the numbers until I get there, right? So there's only one interval previously, so what I'm going to do is 6 plus 7 to get my cumulative total. 6 plus 7 is 13, and that's my cumulative total. So whatever interval they give you, you're just going to add up all the previous numbers to that number to get your cumulative total. And then I need to divide that by my grand total. So 13 divided by, I'm going to add all of these up. 6 plus 7 plus 5 plus 2. That's going to give me my grand total. 6 plus 7 is 13. 13 plus 5 is 18. And 18 plus 2 is 20. So 20 is my grand total. So to get my cumulative relative frequency, I'm just going to do 13 divided by 20. And that's going to give me 0.65. And that's it. If you were to find the cumulative relative frequency for the next interval, I would add up these three numbers and divide them by 20. All right, we're close to the end. All right, so normal distributions. So properties of normal distributions. So they're symmetric and bell-shaped, right? You know what they look like. The mean is equal to the median. So the mean and the median are the same number. You know your empirical rule, which is 68% of the data is between one standard deviation, 95% is within 2, and 99.7 is within 3 standard deviations. All right, before we get to, this is sort of like a bonus type question. We'll talk about that in a second. What is the z-score formula? Z is equal to value minus mean over standard deviation. And when you calculate that, what exactly are you calculating? What is a z-score? A z-score is the number of standard deviations above or below the mean of a certain value. So the number of standard deviations above or below the mean. All right, so here we're going to put together the percentiles with our definitions of IQR. So remember, IQR is your Q3 and your Q1, right? So what percentile is Q3 at? It's at what percent of the data is below Q3? It's the 75th percentile, right? Because 75% of the data is below Q3. So your Q1 is going to be at the 25th percentile, because 25% of the data is below Q1. So if I wanted to figure out how many standard deviations, I'm asking about the z-score, right? Because the z-score is the number of standard deviations above or below the mean. So I'm just going to go ahead and look and find the Q3 z-score. So I'm looking in the center of the chart, because the center of the chart is your area, your probability, your proportion, your percentiles, anything like that. That's what's in the middle, right? The area underneath the curve. So I'm going to look for 0.75. And I'm not going to get it exactly, so I need to find the number that's closest to it. So it looks like 0.75 could be either here or here. So I need to figure out which one is closer to 0.75. And I'm just going to do that by subtracting and see which one has the larger difference. All right, so this one has a difference of 0.0014. Oh my gosh. I'm going crazy. And this one has a difference of negative 0.0017. So the closer number is going to be this one right here. So I'm going to use this z-score. 7486. So the z-score of my Q3 in my data set is going to, oh, I didn't even look it up. So 7486, I'm going to look to the left, and I see 0.6, and I'm going to look up, and I see 0.07. So that's going to be 0.67. So my z-score for the 75th percentile is always going to be 0.67. All right, now let's look at the 25th percentile. So I'm going to look for 0.25 in the table A. .25. Where are you? Here or here? Which one is closer? So go ahead and subtract both of these numbers from 0.25 and see which one's closer. All right, I think you found that this one was closer, right? And what a coincidence, my z-score here is negative 0.67. It's not a coincidence, actually. Can you see that? So it looks like with your IQR, how many standard deviations is involved in the IQR? Well, I have 0.67 standard deviations above the mean and 0.67 standard deviations below the mean. So my IQR in total represents 1.34 standard deviations. So just keep this number close to you while you're taking the test. All right. How do I use table A? And that was just one question, so it was, don't worry, this question was on the test, and I wanted to work through it with you guys so that you could see what the answer was, because I feel like I didn't do a good job of covering that. So just keep this work next to you. All right, how do I use table A if I'm looking for the area, the probability, the proportion, lower than a value, higher than a value, and between two values? So remember, if we're looking at something lower than a value, we are shading to the left. If I'm looking for something higher than a value, I'm shading to the right. So that keyword of lower and higher tells you which direction to shade the normal curve. And then if I'm looking for something between two values, I'm going to have two z-scores and I'm going to shade in between them. All right, so if you're looking for that area, remember your step one is going to be to calculate z-score. Step number two, z-score of z-scores, right? Step number two, look up table A values. Using z-score. And then step number three depends on which situation you have. So if we're looking for something lower than a value, you just take the table A amount. It's the easiest scenario. Just take the table A amount. If you're looking for something to the right of a z-score, you're going to do 1 minus your table A amount. So you're going to subtract it from 1 if you're looking for something higher, if you shade it to the right. So lower, you just take the table A amount. Higher, you do 1 minus the table A. And then between the two values, you subtract the two table A amounts. So those are the three scenarios that we've talked about, right? Alright, so just follow these steps. Calculate your z-score, value minus mean over standard deviation, and then look to see what the question's asking you. Should you be shading the area to the left, to the right, or between two amounts? And that is it. Alright, good luck on the test tomorrow, and email or text me with any questions.